section is mostly vocabulary. So we are going to learn what all of these things in this left-hand column mean mathematically. Function definition and notation, you guys are probably mostly familiar with that already. Domain and range, I know that you've talked about quite a bit. And then there's some other ideas in here that maybe we haven't formally discussed in a mathematical way, but a lot of them have sort of some intuitive meanings for you already, like continuity. Whether something is continuous or not, you can probably think a little bit about that and already have a good idea of what that's going to look like. Increasing and decreasing, pretty simple. Boundedness, whether something has a boundary or not. Local and absolute. Extrema. Extrema is the plural of extreme. So we're going to be looking at extreme values of functions, maximums and minimums, things like that. And then you know about symmetry, asymptotes, and then we'll introduce a little stuff about end behavior, okay? So those are all properties of functions that we are going to talk about in this section, okay? All right, so let's get right to the, so a couple ideas here that are illustrated in this graph. The first thing is domain and range. The easiest way to think about domain and range is that domain is the what?
X value.
Good. Domain is the x's, and the range is the y's, okay? Or also sometimes in like first year algebra you talk about the domains as being the inputs and the range as being the outputs, okay? But we're going to stick with this domain and range. So then one of the questions that mathematicians like to answer a lot for some strange reason is if you're given a function or if you're given a mapping diagram, does it represent a function or is it just a relation? And when I do this lecture in first year algebra, we talk about for something to be functional, when you put something into it, you have to get the same thing out every single time, or else weird things are going on. So for example, when you put your car into drive, your car would not be functional if sometimes it went forward and sometimes it went backwards, okay? You would say that your car is broken. If you're working on the computer and when you hit the X key and sometimes an X pops up and sometimes a Y pops up and sometimes a little smiley face pops up, your computer is broken, it's not functional. So that's what they're illustrating right here. This is a function because every time I input this X2, I get this Y2. Every time I put that in, I get that one. Every time I put that one, I get that one. Notice, this is sometimes a little bit confusing to students. In this case here, when I put in X3, I get Y3. And when I put in X4, I also get Y3. That's okay, okay? And again, to go back to the car analogy, if I want my car to go forward, I can put it in drive, or I can put it into third gear, or second gear, or first gear. So there's different ways that I can get this result. I can do different actions to get this, and I'm still okay. What's not okay is this over here. When I put in X1, sometimes I get Y1, and sometimes I get Y3. Okay, so that's what makes this not a function. Okay, and you've heard this all before, right? So does it make sense? Any questions on? Yeah? All right, I don't know if we get into the vertical line test or not, but you remember that if you can draw a vertical line and it only goes, the pencil test only goes through one point in the graph, then you know that it is a function. Okay, so does the formula y equals x squared define y as a function of x? Yes or no?
Hold on, does the
Is y equals x squared a function? In other words, every time I put a number in for x, will I always get the same answer, or are there different options?
Yes.
Yes. Okay, so this is yes, this is a function. The easy way again to think about this is you all know what the graph of y equals x squared looks like. Parabola. It's a parabola with its vertex at the origin, so it's this thing right here. And so like we were talking about in terms of the vertical line test, if I take a vertical line and pass that across the graph, that will never touch the graph in more than one place, okay? So that tells me that every time I put in this x value, I get that y value as an answer. Okay, so that means yes, it is a function, all right? How about this stuff here? This is the old Sesame Street song. I don't even know if Sesame Street still exists. One of these things is not like the other. One of these things just isn't the same. Yeah, okay. So one of these is not the function. Which one and why?
Why C?
C?
Because you can put a penny.
Okay, good, because if I do the vertical line test here again, there are a lot of different places where I would grab this line and it will cross the graph multiple places. And so again, the reason why that means it is not a function is because if I plug in x equals -1, I don't know if this y value is my answer, or this y value is my answer, or this y value is my answer, okay? So this one is no good, these two are both fine, okay? Now, let's not disrespect these things, these are still important. And later on in this class, for the first time, we will make a little bit of an in-depth study of things that are not functions. Okay, so we'll see how we can graph them and talk about their properties and whatnot, all right? So all we're trying to do now is figure out if it is a function or not. So that's our vertical line test. Okay, then we talked about domain and range. Domain is the x's, range is the y's, so everybody loves that. Okay, so let's practice finding the domain of some functions. So to start with, take a look at f of x equals the square root of x plus 3. What are the two basic laws of math that you can't break, you can't do?
Just divide by 0.
Okay, good. So when we're looking for domain and range, one thing you want to be careful of is we can't divide by 0. Okay? And then what's the other thing that we can't do?
You can't square root a negative.
Can't square root a negative number, okay?
Jeez. Can
Okay, so those are the things that we have to be careful of when we're talking about domain and range. So if neither one of those things is present in the function, if you're not dividing, and if you're not square rooting, 99% of the time, maybe 100% of the time, your domain is going to be all real numbers, okay? But you can see for this one right here, we are taking square root. So what's the smallest number that we can plug into here and still be okay?
1.
1 is okay, because 1 plus 3 is 4, and we know the square root of 4, but I can go lower than that. I can go even lower than that.
Just
What?
hit -3.
-3, okay. Can I do -3?
No. Well, yeah.
Why that always happen? Yeah, you can do -3. A lot of times students don't want the square root of 0 to exist, but it does. What's the square root of 0? 0, okay. So -3 works, okay? But as soon as I get below -3, then this underneath the square root is going to be a negative number, and I can't do it, okay? So the domain of this function, there's a few different ways that I can write it. I can say that x has to be greater than or equal to -3. For some reason, I got a new projector, and the board is more sensitive now. So the domain is that x has to be greater than or equal to -3, or as we become mathematical adults, this notation is not widely used because it's sort of cumbersome, so they do interval notation instead. Did we talk about that last year? I can't remember. So another way that I could write this is -3 to infinity. Okay?
Oh, yeah.
And that's a way that you can write that without using the little alligator mouth, because, you know. So why does this have a square bracket and this has a round bracket?
Oh, thanks.
Go ahead, Morgan.
Square bracket means it's ended and it can't go any further.
Yeah.
Right, okay.
And infinity goes on forever.
And then this goes on forever, right, okay. All right, so how about B? I got two issues there now because I have a square root and I am dividing. So
Yeah,
what are some things, what's our domain, what do we got going there?
5 is one of them.
X. Okay, so we know that x can't equal 5 because 5 minus 5 is 0, and we can't divide by 0, so that's no good. What about the square root?
Has to be greater than 0.
Has to be greater than or equal to, got the eye roll on that one from Evan, greater than or equal to 0. Okay, so you can write this like that. You can say x can't equal 5 and x has to be greater than or equal to 0. Or in interval notation, things get really exciting. That means we can go from 0 to 5, but I'm going to use a round bracket right there because that means I can't use 5. Okay? And then I can also go from 5 to infinity. This thing right here is a U, and it stands for union, so the union of these two sets. Anything from here or from here is in my domain. Any number from 0 to 5, including 0 but not 5, and any number from 5 to infinity. Okay? So that's a little bit cumbersome to do that right there. Okay, and then the last example, and then we'll call it a... no, stay with me for one more. Sometimes the domain of a function is defined by what the function is representing. So in this case right here, you might look at it and you'd say, okay, well, I have a square root, but it's not a variable, so I don't have to worry about that. And I am dividing, but that's also not a variable, so I don't have to worry about that. So if you just saw this all by itself, you would say the domain is all real numbers. However, this is supposed to be the area of an equilateral triangle with sides of length s. So in the context of the problem, what are my restrictions on this variable going to be?
It looks like a
The
5.
side, the length of the sides.
Yeah, so what are some side lengths that I can't have? Can't have 0 because then I wouldn't have.
Can't have a negative number.
And I can't have a negative. So in this case, my domain would be that s has to be greater than 0. Okay, otherwise I have no triangle, and so there is no conversation. And again, in interval notation, we would go from 0 to infinity.
And now it's a day.
Okay? All right, any questions about that? Okay, so we'll take up there on